Hi guys, this video will help us out with the extension for outcome 2, which is a general quadratic. So what you're given in the general quadratic is the general equation of a quadratic function, which is that, and we've seen this equation before, ax squared plus bx plus c. We saw that when we were filling out our graphic organizers. So all quadratic functions kind of follow this form. And what you're doing specifically in this assignment is you're basically proving that quadratic equations always follow the pattern in the outputs where the second differences are constant using the general equation, so using the ax squared plus bx plus c. So on number 1, what you're doing is you're working with numerical inputs, similarly to what we've done in class. So 7, 8, 9, and 10, those are your inputs. And you're plugging those in to the general equation to come out with outputs. Now notice something. There are A's, B's, and C's in this equation, so therefore there's going to be A's, B's, and C's in our answer on each of these outputs. So let's start with 7. What happens if I plug in 7 for x? Well, A would just be A, and then x would become 7. So what is 7 squared? Well, that's 49. So the first term we would have would be 49a. Let me write that. Plus, we have a 7 that would be plugged in here as well, 7b. And let's not forget our plus c. He's just hanging out at the end, so we have to include him in our output as well, plus c. So 49a plus 7b plus c is our first output. Now we can do the same thing with 8, okay? If we plug in 8 here and here, we would get what? 64a plus 8b plus c. Plus 8b. Okay. Now I'm not going to do the rest of this for you because I think you guys could take it from here. But once you get done with this, part B would ask you to find the first difference, the second difference, to make sure that you get a constant something. So how would you take the difference of two algebraic expressions like this? Well, what is 49a minus 64a? Well, that's negative 15, right? Negative 15 a, and 7b minus 8b, well, that's negative 1b, or just negative b. And then we have c minus c, which is just 0, right? Those c's cancel out. So your first difference for these two outputs would be negative 15a minus b. Okay. Here's where the problem gets really tricky, which is number 2. Now instead of working with numerical inputs, numbers like 1, 2, 3, 4, 5, you're working with general inputs. In other words, you're working with variables that can represent any number. Okay? It can represent pi, negative a million, whatever you want them to be. So the specific inputs they give us are w, w plus 1, w plus 2, and w plus 3. Well, what would I do if my first input was w? How would I do this? So if I'm getting this first output, I'm going to substitute a w in for x, and so this is actually quite easy because the output is just going to be this thing, but instead of x's, I'm going to have w. So it would be, instead of ax squared, it would be aw squared plus bw plus c. Okay, that wasn't too bad. Here's where it gets a little harder, a little more algebraically tricky. What happens if I plug in a w plus 1? Well, now all of my x's in the original general equation are going to become w plus 1s. So how would that look? Let's write it out. It would be a times the quantity, in parentheses, w plus 1 squared. Why do we have to use parentheses? It's because we're squaring this whole thing. All of w plus 1 gets squared. Plus b, once again, times the quantity in parentheses, w plus 1. All of that plus c. Okay? So notice how ugly this is. A times w plus 1 quantity squared plus b times w plus 1 plus c. Now I'm going to expect you guys to use your algebraic math skills to clean this up a little bit. Maybe you can try foiling w plus 1 squared and multiplying everything times a, and then you can use the distributive property to get rid of the parentheses here, b times w plus 1, and then plus c you just have to have hanging out. After you're done with each of these outputs, what you're going to do is you're going to once again find the first differences, find the second differences, and you should see a consistent thing. It doesn't have to be a number necessarily. It could be like an algebraic expression for the second differences. Okay? Let me know if you have questions. Feel free to email me or just come into tutoring, ask. Yes. All right. Good luck.